Hey there, welcome to our lesson. Today we're on 612 conditions for triangle congruence. If you don't have this packet, you can just write this in your notebook. And we're going to look at a core problem, and then we're going to fill out some other notes. So our math goal is to learn triangle congruence theorems. So in our last lesson on chapter 6, we talked about the ways that we can show triangles are congruent. So remember, step 1, we want to ask, okay, are they similar? Okay, and remember the ways that we have to show that they are similar. We could use angle-angle similarity. We could use we have side-side-side, side-side-side similarity, and side-angle-side similarity. So if we look at this, we are going to start with that step 1. So we are going to try to show that they are similar. So in class, to do that, we worked on flowcharts. So we're going to start, I can see that these parts are labeled the same. So I can say AC over DF. They are marked as equal. So whatever number they are, if this was 5, this would be 5. If this was 105, this would be 105. So when we divide a number by a number itself, that's equal to 1. Okay, there's our first bubble. I can see the same thing happens right here. So I can see that AB over DE is also equal to 1. And I can see that this is marked, and this is given information. This was given to us. It's given in that picture. It's given in that picture as well. And then we're given that these angles are the same. So we can say the measure of angle A equals the measure of angle D. And that was given. And so I can see in on my picture that we have side, angle, side. So these triangles are similar, and that's, of course, like I said, step 1. So we can say triangle ABC is similar to triangle, okay, ABC, DEF. By side, angle, side similarity. Okay, so that's step 1. Step 2 involves us figuring out the side ratio. Okay, so I put step 1 up here. I'm going to run out of room. Step 2, side ratio. Well, we can see right there, they were the same. They were marked as the same. So that's equal to 1. So therefore, I don't really want to write therefore every time. So I'm going to put these little dots. Okay, when I put these dots, that means therefore. I just don't want to have to write that every time. Therefore, the triangles are congruent. So instead of just this, I can say triangle ABC is congruent to triangle DEF. And again, if you were gone, this means is congruent to. So right here, this tells us that if we have side, angle, side, and they're marked as congruent instead of a side ratio, that tells us that those triangles are in fact congruent. So we just showed that side, angle, side works. So if you have this packet, we're going to turn the page. If you aren't done writing, go ahead and pause and then come back. If you are ready, great. So we just showed that side, angle, side works, which isn't on here. These are the other ones that could potentially work. Okay, so let's just kind of quickly talk about this. Well, if these are the same, right? If all of these, A over A, well, that equals 1. Right? B over B equals 1. C over C equals 1, right? This is side, side, side. We know they're similar, so then they have to be congruent. So yes, congruent. Angle, angle, angle. If we have three angles, do they have to be? They don't have to be similar. So they're not even similar. This is hypotenuse leg, which is kind of tricky, but it's a Pythagorean theorem problem. We could use, because it's a special triangle, it's a right triangle only. Only in right triangles. Really, we could use the Pythagorean theorem and show, like if we called this A and this was C and this was A and this was C, we could show that B would have to be equal, that B would have to equal B. So hypotenuse leg gives us a congruence. Okay, angle, side, angle. Well, right away we have angle or angle, angle, side. As soon as we know that two angles are congruent or two angles have the same measure, then we have similarity. So yes, similarity. And then look at this ratio. Side ratio equals 1. So yes, congruent. Okay, if you want to try out the last two and see if you can reason through them, go ahead. But we're going to now go into our yellow sheet that you should get from the front if you haven't gotten it yet. Otherwise, we are going to fill this in together. All right, so looking at this, we've got, well, what's given to us in this information? We have angle, side, angle. Right? Angle, side, angle. So we could label this as A, B, C, and K, L, M. All right, so we know that angle A is congruent to angle A, or angle L. We can say that they're congruent, or we could say that their measures are equal. The measure of angle A equals the measure of angle L. Okay, that was given. We can say that this side in between, okay, so this is important. It has to be the side in between. That side in between is the same, right? So that ratio, side ratio is 1. So we can say AB over ML equals 1, right? They're marked as the same. And then we can say the measure of angle B equals the measure of angle M. That was given. This was also given in the picture. Okay, they're marked as equal. That's what that little symbol means, okay? Remember, it means that those parts are equal. So we can say, now we can change, and instead of showing similarity, we can now show a congruence. We can say triangle ABC is congruent to triangle, so we said A, B, C, L, M, K, by angle, side, angle, congruence. Okay, angle, side, angle, congruence theorem. So if you are given a triangle with two angles and a side in between, then those triangles are congruent. Okay, so this is the congruence theorems. Okay, the one we just did in class discuss just now the example that I did. I can see side, angle, side. Okay. Side, angle, side. Up here, I should have put congruence. Here, I should put congruence. So again, I can see that these things are labeled. We just proved this to be true. So again, I'm going to call it A, B, C, and X, Y, Z here. So we're going to write a proof of this to show this to be true. So AB over XY, or XZ, sorry, XZ equals 1. I can see BC over ZY equals 1. And I can see the angle in between, the measure of angle B equals the measure of angle Z. Okay, all of this was given. Given. So because of these 3 reasons, okay, side, angle, side. Again, this has to be the angle in between. So it has to be the angle in between. It's got to be the angle sandwiched between the 2 congruent sides. If you have that, then we can say the triangles are congruent. Triangle ABC is congruent to triangle XZY. And that's by side, angle, side congruence. I'm going to do one more. You can try the last one. I'm going to do one more with you. And then if you don't get it done, we will look at it on Monday in class, or our next class, whatever next time I see you. Okay. So, and again, if you didn't get those, rewind, watch again, pause if you need to. So here we have angle, angle, side. Well, I can see that with angle, angle, I have similarity because I know if there's 2 angles that are the same, the triangles are similar. And I know that this must make them have a side ratio of 1. So that's why this works. So this is called angle, angle, side congruence. Okay, look at the difference here. Angle, side, angle, 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 side. So anytime there's 2 angles, we're good because we already said if there's 2 angles, we know they're similar. All right, so we're going to label, let's go with J, K, L, and X, Y, and Z. All right, so we can say the measure of angle K equals the measure of angle Z because they told us, given, you can write that inside or outside, doesn't really matter. I wrote it inside here, I wrote it outside down there. Next up, the measure of angle L equals the measure of angle Y, given. So again, we know they're similar. We have 2 angles. The last part is the congruence part. So these are equal to each other. JK over XZ equals 1. That has a ratio of 1. I'm running out of room. So I can say triangle JKL is congruent to XZY. Oops, triangle XZY by angle, angle, side congruence. So far, all these have 3 bubbles, okay?
give this a try. I will take a look at it. Okay. And then we will hit up the bottom too the next time I see you. I think that is all I have. So thanks for watching. Bring any questions you have to me. I appreciate it.